Hello everyone, and thanks for joining this talk. We have 3 hours today to talk about the ways unit testing help us improve our design, give us hints on how we can improve our design. But before we begin, let me introduce myself. My name is Victor Rentea, I'm from Romania. I am a Java champion, and for the past 10 years I've been doing consultancy and trainings in various companies throughout Europe. My favorite topics are clean code architecture, unit testing, and that's exactly where this section comes from the unit testing workshop, basically. And now I'm in that part of my life in which I need to give back. So this is basically a part of my workshop. Spring Hibernate Reactive Programming. After lunch, you have 3 more hours if you want to join about Webflux and how we can master the most difficult programming paradigm in the world. You'll see how many pitfalls are there. Performance and secure coding. You can find me on YouTube, and I have a community that I'm very proud of, which has become the largest community in the world on software craftsmanship. Software craftsmanship basically means these things: clean code architecture and unit testing. We are 6,000 developers throughout the world, meeting online every month for 1 hour after work. And you can see the past events on my YouTube channel. And because there is life after work, I have 2 kids, a cat, and a garden. All right, so let's get started. Let's turn back time to 2001, to the dawn of Agile, and they had a dream. They had this wonderful dream that while we keep shipping working software, the design of the software will gradually improve by itself. All right, that should have happened. The problem is that rushed by deadlines and hotfixes and running to understand what goes on in there, we spend too little time to improve the design. So we need triggers. People need triggers. I need triggers. Someone should tell me. Something should tell me when I should improve the design, when I should invest more into cleaning the solution. Now, writing unit tests might be the missing piece. Back in those days, they were talking a lot about testing, about test first, about test driven, about a lot of testing, and that should be part of our culture, and it is in many of our companies, indeed. But are we listening to those tests enough? Right? You know that if tests are hard to write, the design sucks. I mean, that's an old adage. I mean, we knew that already. I want to first meet this guy. This is my favorite guy on earth. This guy Ken Beck invented extreme programming back in the 1990s. He is I should have asked first, who knows Kent Beck? Let me raise your hand, please. All right, that's more than half of you. Oh, phew. Right, so this guy invented basically TDD. He's the author of JUnit and is considered to be the father of unit testing. Right? And Ken Beck has these rules that I really, really love. The rules of simple design. The first rule is that the design is simple if it passes all your tests. That's a problem for many teams. They're like, oh, what tests? Oh my God, right? But if you wrote those tests that proved your stuff works correctly, that grants you freedom, safety to refactor it later, and that also, the purpose of this talk, gives you a ton of feedback about how to improve your design. Second rule, your code should use clear, concise, consistent domain names. You can read here ubiquitous language if you want. And there should be no duplication, of course. I shall not copy-paste code. And besides those, don't put anything extra, unless to meet one of the goals above, right? So keep it simple, keep it minimalistic. Avoid over-engineering. Now, what's this? That's an ice cream cone, right? That's the famous ice cream cone testing anti-pattern. The reality in many legacy systems today, in which they hire a QA. Ever heard of a QA department before? QA department, 30 clickers, and then roughly any integration test, maybe some UI robot testing, and scarcely just starting to build some unit testing. In total, the coverage is not enough to grant us freedom to refactor, isn't it? Now, how we approach testing today, as you probably all have heard, is the testing pyramid. We want to write many unit tests, right, to test slices of behavior. Maybe more tests that test groups of classes together, and then just a few of them that go the whole path through the entire flow. The higher you go, the longer paths you cover, and of course, the more expensive they are and more flaky they are, because anything can break on that path, right? On the opposite, here in the bottom, these are extremely fast and extremely cheap to build and run, right? Now, the checkout flow of an e-shop, I want to check up there because I want to make sure it works in reality. Whereas some quirk of implementation, some edge case, I'm going to test with a unit test. Now, the overlapping of these sections in the pyramid is not accidental, of course. The same feature should be tested at different levels. The checkout flow should also be tested again in service integration level, and so on, right? And of course, we are supposed to write more unit tests than end-to-end tests. This is what this picture is trying to tell us, basically. All right. Now, deep down here in this basement, we can find our friends mocks. Are they friends? Let's see. Now, with mocks, we developed this love and hate relationship. At the beginning of our career, we love mocks. I mean, everyone loves mocks. It's so cool. I mean, like, you can just put your test to work even if you don't have a database up there, right? I mean, like, it's so fun, right? You don't need to call an API, you just put a mock. I mean, like, it's for free. Look how easy it is. However, we've found ways in which we can isolate our systems without mocks, such as using an in-memory database or test containers or wire mocks and mock servers. We found ways to make our tests isolated. No one wants a test that either fails or passes for unknown reasons, for random reasons, for external reasons. You cannot base any decision on these tests, can you? Right? Now, the one argument in which no one beats tests with mocks is they are super fast. You can't possibly have 10,000 tests running in a couple of minutes unless you build them with mocks, of course. If you fire up containers, if you fire up applications, you can't possibly get that much speed, right? Now, those two above are pretty obvious, but the one below is what attracts most of us. Hey, we can test less logic. We don't need to go the whole path. I can just test my patch, my hotfix, just my own little change. I don't need to care about anything else, right? Now, that makes sense. If you have a method having a for, and then an if, and then a for, and then one more if with 3 conditions, and then a d, you would need a lot of tests to cover this. Of course, you will need a test to go into the if, you need a test to have this false, maybe to have that false, and there will be a lot of tests to write on such code. Right? This is sometimes referred to as cyclomatic complexity or cognitive complexity, as Sonar puts it. Now, the more codes, the more execution paths you have through some code base, the more tests you need, of course, right? So then, if you have an f function with 5 execution paths, calling another function, g, with 6 execution paths, if you try to test them both together, how many tests could you maximally have to write? If there are 5 in the first, 6 in the second. In the worst case scenario, how many tests would you have to write? 30. You need to multiply them. Who knows what happens if you go left there and right there? They might have impact in the worst case scenario. In practice, it never happens to be 30, right? So you see, the more paths the longer the path you traverse, the more tests you would need. And also, heavier tests, because to take 11 ifs, left, right, left, right, left, right, you need a lot of input to go that deep and to take so many turns. So in some point, mocks are inevitable. You can't really build a non-trivial application without mocks. I mean, I dare you to do that, but it's really hard. Right, now, there is one guy out there who believes testing less logic, he might be cheating. I won't debate that right now. I'll just invite you to give it a read. Don't give this PDF to juniors, please. It might. Be careful. Be careful. Right. Now, why we hate mocks, we need to say that out loud. Why we hate mocks? Because we can slip bugs to production despite having thousands of green tests. For example, this. Unit testing, perfect. Integration testing. Oh yeah. Let's play it again. Unit testing, it's just perfect, isn't it? And then integration test. Excellent. Good. And there are more. My personal favorite is this one. Integration test. Boom. And then you see the unit test goes perfect. Perfect. I mean, like, the umbrella opened. All right. So the connection was the problem, all right? So it can slip bugs to production. Anyone had bugs in production despite green tests? It's like, what? 70% of you? Good. Now, tests written with a lot of mocking are famously fragile, famously hard to refactor, they might impede refactoring. And we started writing unit tests to grant us freedom to refactor, and now tests might impede us. And also because they are impossible to read. Now, for the rest of this discussion today, we're going to juggle with presentation and code. In the left side, you will see the production code. Keep that in mind. So in the left is production. In the right is the test you have to write to test that that production code. Right, so let's imagine we have this beautiful, actually that should be vice versa. Imagine that you would encounter such a test class. Anyone, rings any bells for anyone? Anyone feeling now comfortable back home? Excellent, excellent, good. And then the test, of course. How can you possibly understand what goes on in there? There are a lot of interactions with the outside world, but I didn't tell you the best part, right? You are perfectly okay if you ask yourself, what the heck am I doing? What am I testing in here, right? But I didn't tell you the best part. The production code had 4 lines of code. So all that madness for 4 lines of code, are you for real? I mean, what are we doing? Where are we? Look, if you have the method in the left, right, would you unit test it? Perhaps, but can you imagine how many mocks you need in there? 1, 2, 3, 4, 5. 5 mocks to test 4 lines of code. That's a madness of test code to write. Right? So some would say burn the test. We are not in this business to cover this kind of. What is the risk for that ever? I can't tell you that. I can't. But I have colleagues that say that. Don't test it, goddammit, it's no use. What I will tell you instead is I will invite you to try to simplify the production. So look, you might have a function now somewhere in there looking like this, like repo save mapper from DTO, and then a find. This is effectively 1 line of code that would require 7 lines in a test with 3 mocks. My challenge to you guys is, do you really need this function, or can you just inline it? What do you mean inline it? Destroy it. Simplify the production code to basically put wherever the function is called, put that line in there. Now, of course, you can't do that every time. If you call G from multiple places, or if you have to follow some architectural guidelines, hey, I can't put in the controller a repository. I can't inject in the controller a repository. Or can we? Anyway, there might be some architectural guidelines you want to follow. So that might not allow you to do these kind of changes in your production design. But then I'm going to tell you, why don't you take a step further away and you test the whole story as an entire flow? This is called honeycomb testing. Remember the pyramid we've mentioned before? That's for monoliths. That's when it was invented. Now, what's the difference? Well, in a monolith, you will have rather few APIs, and you might find in there terrible complexity. Hidden under several APIs. Testing that deep complexity is virtually impossible unless you're using some unit tests to do that, right? In a microservice architecture, however, accumulating that complex behavior in a single system is not the best thing to do. Microservices also have more APIs, which are stable. So these are perfect testing surfaces to attack, right? Again, what's inside the microservice, you wouldn't see that much logic as you would in a monolith, right? Now, another problem that microservices have nowadays is the proportion of bugs that they have in configuration. I'm going to ask you a bold question here. Is any one of you having recently more bugs in their configuration than in their logic they wrote? Just a couple of hands here, but there are sometimes people in the room. So you might get in this point in which you have more bugs while configuring the libraries. It's natural, the libraries have evolved. We write less and less code because we keep solving the same problems in different projects. Now, my point here is that I will invite you to test more at an API level of a microservice, which is sometimes referred as the honeycomb testing strategy. Now, without falling into all the details, I'm going to come back to that tomorrow when I have another talk on this. The idea is that it's now a hexagon, and hexagons are very fancy these days. Everyone does hexagons. Hexagons are cool. So you see, we have integrated at the top, which stand for the end-to-end tests, like in the pyramid before. We have integration tests, and I'm not making this up, folks. This is Spotify, right? So this is integration flow in the center, in which you have many calls to the flow that you have in a single microservice you will have to put a lot of tests in there, but then to keep your tests isolated, you want to block or to control all the connections to the outside world. Therefore, you're going to put a wire mock or a test container beside. And then what happens? You have isolation, and you can test a microservice as a whole. Right? I don't care what's inside. That function in the previous slide, I never see it. I'll just fire calls at the API, and I'm good to go. All right? Nice. Now, this complexity, in any system we're going to build, there will be some complexity at some point. Otherwise, what's the purpose, right? When you encounter such complexity, what I want you to do is to cut it out and to test it in implementation details, the former unit tests, if you want. Now, in that section below, you're going to cover one class or a group of classes, right, which are naturally isolated, because when you have a lot of complexity, that complexity tends to self-delineate. I mean, like, it tends to take shape as a whole. When you see this complexity, like, I don't know, computing the price of a cart, applying special offers, estimating the risk loan for a bank, for a credit application. This is a highly complex piece of logic that is well delineated, and it's a very good candidate to test in implementation detail tests, right? And you are allowed, in this case, you are allowed mocks. Good. Okay, now, whenever there is complexity, you're going to test it with implementation tests, or unit tests if you want. And when we're going to do that, we're going to work with a lot of mocks. Now, the fun thing is that this testing things close by is going to give you this feedback, because tests, if your production design is crappy, tests are going to be extremely painful to write. And tests are the first guys in your code base who are going to hurt you if your production design sucks. So, my point here is that if you have some wildly evil 10,000 line C++ function, you can test it from the boundary. You won't see the dragons inside. But my point is, if you test black box, like integration test up above, you won't see what's inside the box. You will just fire at the API and then control the connections to the outside world. Fun. But you can't possibly test every corner this way. And when you face complexity, you're going to unit test that complexity. And the moment you're going to unit test the complexity, you're going to open the code and you're going to see dragons. Right? You're going to say, oh my God. And that's going to be your feedback. And this is very fun, because code starts small, the flows, we start in the how many times have I heard, oh, it was supposed to be just a CRUD microservice. 5 years later, the new monolith is here, right? Things grow. And as they grow, you have to have feedback when they are big enough, right? So when you can't possibly cover all the branches with integration tests, with basically testing the microservice as a whole, you're gonna fall back to implementation details, and that's gonna open the Pandora box for you. You're gonna see what's inside, and you're gonna have to clean it, right? So it's an evolutionary approach in which you throw tests later in the game. You might have heard of the outside-in TDD, but I don't want to use today too much the word TDD, because this started to have the feeling of a religion. It's not. It's just the concern of it's just about concerning yourself. How am I going to test this? Right? So I'm going to test it at the API level, and then slower, and then later, when the complexity will grow, I'm going to open the box and see inside and test, and unit test the details. All right. And here we're going to meet our friends mock again. Fun. So let me turn back time, like what, 20 years ago? Oh my God. 20 years ago, I was just, second year of faculty. And these guys in London, they were inventing mocks. And they had this paper. This is a scientific paper. Anyone saw this format before? Anyone in a PhD or master's degree business here? Just a few of you. Too few. Interesting. This is a scientific paper about how we can burn ourselves while using mocks, written by those who invented mocks, right? And these guys over here, the title was very fun. Mock roles, not objects. What does that want to say? Let's see. Suppose you implement a new feature, right? You click, you then write some stuff, and then, hey, let's test it. And then you open up the Postman, click, it works. And then, wooha, congratulations. And then, testing. I forgot to write tests. What do you do next? You write tests. But because you're out of time, how many of you have left out of time where you were starting to write unit tests? Huh? Yeah, that's 30%, interesting, maybe less. So when you are out of time, when you have to write your unit test, what you're gonna do is you're gonna just copy the dependencies, blindly mock them, and you're good to go. There is actually, I don't want anyone else to hear, there is an IE plugin that can generate shitty tests. Any kind of production code, you throw it. It's absurd. But anyway, the point is, years later, the team complains your code is impossible, your tests are impossible to work with. They break any change you do in your implementation. Of course they do. Of course they do, because that's a bad habit. You see, when you put mocks to play in some code, you have to think about the contract of the thing that you are mocking. Because once you mock it, it becomes 10 times harder to change that API. Because then you have to change the test on the thing and the test relying on a mock of that thing. Right? That's a very, very nasty problem in practice. So the moment you put a mock, you should be super clear what that class does for you. And it might not be the case sometimes. Let me show you a simple, silly example. The examples are deliberately super simplified, most of them, to be able to fit the time, but it can take more than a day to discuss all these in details. Right, so roles. I'm gonna just fire some first code at you. Let's see what you think about this. Let's read from top to bottom just once. I'm gonna guide your reading to gain time. We have here, I have a problem though, I can't see my dear beloved. Oh, thank you. So we have the parcel repository, and then a display service, and a platform service, and a tracking service, and a provider repo. Okay. Process barcode. Barcode int warehouse ID. Okay. The first thing I do, I go to parcel repo to find by barcode. I can read that. It's good. Delivery service display parcel. And then, if parcel is part of composite shipment, then display multi-parcel warning. Now, put it in this simple in front of you, I think it's already obvious what happens in here, but let me show you the test first. Hell yes. This is a test for this code in front of you. Now, writing this test required how many mocks at the beginning? 1, 2, 3, 4. I did exactly like I told you. I copied here, I put there, paste, and then I replaced these with mocks. Done. Professional. I'm a professional and done, right? It's super simple. But, have I looked at the responsibilities close enough? Are they clean responsibilities? The tests are hinting you that the production can be improved. Let's see how we do that. Well, first of all, display service, display parcel, and then if parcel is part of composite, display multi-parcel. Anything fishy here? Right? The API between me and the display service is too wide. Display service does not encapsulate its behavior. Because why does it have the second line? This. Why can't that guy do what this line is doing? So look what I'm proposing you to do. I will take this out of here. I'm going to go here and put it inside. Now, of course, this function could be called from different places. You might need to create another function dedicated for your flow. But the point is reducing coupling between the parts of your system, minimizing the API between the two. Make sense what I'm saying here? Right? Having sharp responsibilities. Good. Now, folks, just in case you want to communicate with me, I'm afraid you have to shout. I don't mind if you do that. I would love to hear your voice in physical, but you are too far. Okay? But hunt me down afterwards. I'm all yours throughout the day. Good. Now, platform service add parcel. And then tracking provider repository, and then find by tracking number, and then tracking service. Wait a second. Why am I fetching the tracking provider from the repository and then passing it to the tracking service? Isn't that guy's responsibility to talk to its repository? So you see what goes on here. I have my service. There is also the service of the tracking, right? And then we each have our own repositories, right? But what I'm doing over here is that I'm talking to the repository of that guy. Am I supposed to do that? It's not entirely wrong, but since I'm also talking to the tracking service on the next line, why isn't this guy doing the job for me? You see? So it's about minimizing the API, promoting loose coupling. Okay? So let me take this line from here, go inside, and put it in here. Now the tracking provider's parameter is no longer needed, but I would need to take the parcel as an argument nowadays. So I will need to take the whole parcel here. Actually, yeah, let's do the refactoring this way. I'm going to say parcel, Alt-Enter, add the parcel to the other side. And then here, using this parcel, I can make the tracking number become unneeded. Good. This is grayed out, Alt-Enter, destroyed, done. So this is the facade, this is the class that is left behind. You see, are they good with colors? Can you see this is grayed out? Excellent, ladies and gents, we have a unused dependency. So let's do what we must. Not so kind. More brutal, please. Thank you. Excellent. Cut. Good, excellent, yes, we kill code. Every senior in the world wants to kill code. Right. Pay attention, the complexity moved to the outside. You have to test it in there, right? But your code is focused on, it has a, let's say, if you change anything in the way the service talks to its repository, that change won't be visible here on the other side. If you change how the tracking service talks to its repository, no one else is going to find out. That's a good thing. That's loose coupling, you see? So that's what I was talking about. Instead of testing small classes each in its turn, right? I mean, like, think first about responsibilities. Do they have sharp, clear responsibility, or I'm just throwing mocks in place in some code that I did not yet really understand and clarify. To see the tests, how the tests improve, we should also have a look at the tests next. This process barcode here, right? Once I've cut this dependency, I don't need tracking provider repo anymore. So anything that I was supposed to take from the tracking providers, that's not visible anymore. Then the process barcode, the class, the test is in the left, the test is on the right. What we have in here, I don't need to. So when parcel repo, that is still there, correct? Display parcel is still there, correct? But display multi-parcel warning got inside this display parcel method, so that is out. Add parcel, mark departing warehouse, and that's it, right? The code simplifies a bit, less interaction between the classes, and therefore simpler to understand code and simpler to test code, okay? So, another thing that could happen, besides clarifying responsibilities of a class, it might happen that sometimes when we play this technique of testing each class in isolation, that can lead us to fragile tests. Whenever we change anything in the interaction between A and B, the tests we wrote here and there are going to blow. So what I propose instead of writing solitary unit tests, by the way, I'm not sure if you heard, unit tests are of two kinds, solitary and social. Solitary unit tests test one class in isolation. Social unit tests put more classes to play in one component, in one larger chunk together, right? So we might decide to test A and B in the same game, in the same test, not mocking all the dependencies of each class. What do we gain? The refactoring between A and B won't break our tests. But what we lose, we need to go through more code. We involve in our test A and B. So it's a small step for humanity, a small step towards more integrated tests, towards more end-to-end-ish tests, right? So you might wonder now, does this happen to me? Let's see. I now have another example for this kind of social testing. Here is a product service. Okay, simple. You might say, okay, too simple. Yeah, but I've seen so many projects whose code is not super more complex than this. So product repo find by ID, product mapper, 2DTO. So we have a mapper. Ladies and gentlemen, we have a mapper. Okay. And then because we have a class, we need to test the class. Right? I mean, like, that's what most people think. Let's create a test for this 2DTO thingy. Let's see. I'm gonna put the test to the left. I'm gonna Can you still read it? Yeah. I think this is good enough. A mapper test, and then let's try to say new product. All right. And let's call a friend. Let's call a friend to the party. Hey, product. Yes, indeed. Yeah, exactly. Thank you. And then I need a new product mapper. If AI can do it, something is fishy, isn't it? Hey, okay, but we did that already. Let's send a product mapper dot. Oh, I have to create this a variable. Of course, I'm sorry, Copilot. I didn't pay attention. No, thank you. And then what comes? Okay, you can do better. Come on. Come on. You can do this. But what? Sir, that product mapper? No, that's not what I want. I want to take this and put it in a DTO, and then unleash hell. Let's see. Yes, thank you. And yes, and yes, and yes. I'm right. I deserve my money for today. I wrote code. Look. So and then I get the salary. Excellent job. And does it pass? Now, passing a test you wrote with AI. You should be super careful, folks. So AI is not for children. That's what I tell my daughter, but she still uses it. Anyway, what I'm going to do next is called mutation testing. I'm going to blow up production to see if the test is failing. Thank you. The test is failing. Right? Applause. Thank you. I broke production, right? I broke production to see. This is called mutation testing. We should all in the room be able to do that. Tentatively break production to see if the test really blows up, right? Yes, it blows up. Thank you. And so on and so on and so on. There are frameworks doing that, you know? There are frameworks doing this. Few people are bold enough to use it, but anyway. So there we go. We have a test for the mapper. Okay, you could say that made sense. The test that won't make sense is the next one, that is going to focus on the product service. And I'm going to test this baby. How am I going to test this? Of course, with mocks. What do you mean? I've tested the mapper, and I don't want to talk to a database. So let's see. I need a mock product repository. Thank you. Repository, good. I need an inject mocks into a product service. Good. And I need another mock to the mapper. And that's the mistake you were doing over here. It's called product mapper. Good. And now I just wonder. Okay, yes. So I want to say product service dot get product of 1. Excellent. That gives me back a DTO. All right. What next? Let's see if I need to do when. When what? When the product report. There. Thank you. Okay. Let's see if it's really right. New product. Is this the right one? Yes. And then to do any. That's another thing here. Do I want to do any there, or I want to? Let's make it as, let's say, explicit as people write it usually. All right. And then return a product. I wonder what did I do wrong. It's a product. Then return. That's an optional of course, because it's a Spring Data repository. Good. And then after that, I need to, let's see, verify. I need to verify that the 2DTO function was called, and then maybe some people actually verified that the product repo was called. What is this test actually testing? 2 lines of code? That's the problem here. We wrote 5 lines plus the dependencies of whole class to test 2 lines of code. Is this really the way? Right? These are both solitary unit tests. Okay, how would a social unit test look like? Let's write one. So we're going to start with the one for the mapper. We're going to take this test from here. I'm gonna product service like this equals new product service. Now this product service takes 2 dependencies: the product repository equals mock of the product repository. Okay. And for the mapper, I'm going to do something wild. I'm going to pass the real mapper. Product repository, let's shout this is a mock. And then the new product mapper. So you see what I did? I created the test2 class with a mock and the real class next to it. Then what? Then I will need the product. Let's take a product out. This. I'm going to pass to the product service the create product, not create product, it's called get product for some number. Good. And I'm gonna have the when. So you see, basically I'm merging the two tests together in one single test. I'm taking stuff from there and stuff from here. Product repo mock, return the option of product. And then the DTO that is out, I'm gonna just assert like that. Not a big deal if you read between the lines, but the idea is that I don't have two separate tests, I have a single test, right? So if there is not enough complexity to justify a satellite class, test it in the whole party, in the whole component with the parent, let's say. Okay, back on here. Okay, so component test, not class, not a test per class. That's what I'm trying to point here. However, this might surprise some people, saying, hey, that's not unit testing anymore, because you have more classes in the same test, really. I've heard so many times unit testing means mocking the dependencies of a class. I've heard this many times when I ask the question, what's unit testing? This is wrong. This is not what unit testing was supposed to do. Unit testing is supposed to test roles, well-defined, clear responsibilities. Okay? And that should be the first hint from the tests. So you should think in terms of responsibilities when you approach unit testing. Otherwise, it's going to blow up. Otherwise, it's going to be a mess. Right. That was the hard part. Now the code examples should be self-explanatory. But let's see. The next hint that unit tests are giving us is when we call a method passing in an object which is too large for what's really supposed to carry. I think the code example is simpler if I put it right now in front. Let's see. I want to have a signatures. There. Look, you might see a code base looking like this. Send sprint finished email taking in project. Now, the project object is a large class with a lot of fields. Imagine, a lot of fields in there. Now, do I want to pass the project in if I only take the email of the product owner? Clean code tells us to take the least amount of things we need, right? So testing this class is also cumbersome because testing it requires me to create a project, new project. That's not fun because if I want to do this many times, I'm gonna have to create projects and projects and projects. And I think the change is pretty simple here, it's pretty obvious. I'm not gonna take the project, I'm gonna take just the string, right? And that will simplify the testing also. I wouldn't have to create the product in the test, of course. So let's take this as a parameter. I'm gonna say project owner email, and that would make the test over here. Well, I can just pass this string in. I don't need the project in this test at all. That was too easy, right? So methods should take the least amount of parameters. Of course, that was basically maybe too easy. Many times you have more stuff coming out from the project structure, right? But still, look, many times you look at the test and say, you wonder, why am I constructing this just to pass an object that has just few fields necessary? So the idea is that if you have an object with a lot of fields, don't pass a large object to a class when instead you can just pass the two things you really need, okay? Of course, like this. Now, the nasty problem happens when you have more than two fields, more than two things, or 3 or 4 or 5. In that case, if you have a lot of fields used inside the function, you might decide to introduce a parameter object. Okay? That's a refactoring in which you group together the things you need in a new object. However, that's heavy. That might be over-engineering sometimes. That only makes sense if the complexity that you're trying to cover with your tests is big enough, is high enough. I would introduce an object just to call a function that has 3 tests on it. I might introduce a new object if I call a function that requires 13 tests. You see, the more complexity is the function, the more you invest in the data structures surrounding that complexity, always, right? So if we are facing highly complex logic, we might group. Don't pass the hero in a game, for example. Don't pass the whole hero to compute the damage. pass only what's necessary from the hero attributes to compute the damage. Or don't pass the whole application, loan application, just to check the person in some registry. And pass the least amount of information you need, right? Even if that means grouping them in new objects. Sometimes it makes a lot of sense. If with this new class you simplify 13 tests, they are justified. Okay, production is simpler to understand, to see what comes in the function as data, and also tests are much easier to read. Just new stuff. Let me tell you the name of a class which justifies this: price calculation input. You could say, why didn't they pass the whole cart? The whole cart. They passed just those things that they needed, right? They've gathered them in a new object and they pass the new object. You're gonna see this later towards the end when we're gonna talk about pure functions applied, this idea. Right. One more thing here, please do not ever mock getters. Although that's, to me, I've seen it. I've seen people having an object so big that they couldn't possibly create. Can you imagine this? Like, so big. And they started mocking the getters. The test suddenly was absolutely gross. 2 days later, they made the mock return another mock. You know what matryoshka is? Like puppets in puppets? Some Russian dolls that are the same. We have a mock and inside, yes, another mock, and inside, another mock, and inside, another mock. Beautiful. The last thing you want is to, in your production code, when you are trying to understand what happens when you call it from tests, you would look at an object and wonder, is this real or is it just a fake? It's absolutely insane, right? So what you want to do instead, we mock behavior. We don't mock data. We instantiate, we construct data. Okay, but wait. Some of you are now thinking, oh, Victor, I construct data, but wait a second. You should see my project. I know. Some people out there, there are two situations in which you can't really construct an object easy. One situation is when you use the so-called, how I call them, constrained objects. Anyone heard of domain-driven design? Domain-driven, whoa! Eric should say this. Right. Like what, 80% of you? Nice. In domain-driven design came this idea that objects should reject them being created in an inconsistent state. You should not tolerate the customer. Customer should throw exceptions if you try to construct it with a null name. Or the interval should not tolerate to have start less than the end. I mean, like, interval goes from this to this. You can't have start, right, greater than end, right? Objects validating their internal state. These can be mutable or immutable. Right, and if such a constrained object grows big, I mean like 20 fields. 20 fields out of which 7 are required. Can you imagine this? 20 fields out of which 7 are required. And if the object, if you try to pass a null because it's not relevant for your case, the production code goes boom. Can you imagine this? Like 20 fields and 7 required. That's one problem when construction becomes painful. The other case is when you try to stick a long test through a lot of classes, be it social or integration test. I remember seeing the checkout of a very large Dutch company, and the checkout came with a huge data structure. But of course, because they were testing like 50,000 lines of code in total, it's a lot of paths to go. Constructing such objects is criminally hard. Therefore, we cheat. And we use a technique called object modder. It's basically a class with static methods that produce canned values. You've heard of this, right? Like, produce values pre-configured, like default values. Right. Then what happens next is that you take those values and you tweak them further. However, when he talked about this idea in his article, Martin Fowler came with a very interesting concept. The concept of having them using meaning personas. So you see, the idea is this. Imagine John. Let me make this larger. Imagine John is an employee who just got hired last week, right? It's a new hire. can John go sick for 2 months? Everyone knows John. John is the new hire, right? And then here goes the test named John tries to go sick for 2 months. But we all know John because John has become a persona. John is now part of the requirements. John is in the mind of the business. Everyone talks about John. Everyone knows John. John is the new hire, right? It's the next level in using object models to come with, let's say, Musk. Anyone knows Musk, this guy? So let's imagine it's a customer with infinite budget. What do you do if Musk wants to purchase something, but he can't pay for the moment? Would you reject the order? No, you're gonna ship it anyway. So personas that are representative business examples in our project, right? Now the nasty part about the object model is that they tend to grow. Anyone here having such classes more than 500 lines? Whoa, I didn't expect that. Like 20%? Very fun. So they grew, and what do we do with them? They became too large, right? And another thing that happens is that being so large, they have their own gravitation system, you know? And anything that you want to write, you put aside, and then everyone ends up coupled to that class. And the new guy on the team comes there and changes one of the methods. Can you imagine this? Then tests blowing up, 30 tests failed. He didn't write any of those, but he changed the method inside the object model, right? So the rule to follow here is that you never change what's written in those 1,000 lines. You just take the object and you keep tweaking it for your needs, right? It's like a default value that is like the genome proximum and the specific difference, the standard object, and then you tweak for your needs, okay? All right, fun. But object model can also give us some design hints. For example, imagine the same object model, large object model, being used in 2 different verticals. Now, what the heck is vertical? So many of you being aware of domain-driven, I'm going to say bounded context, right? Maybe they are used in different bounded contexts. Then something fun is going to happen in a monolith, at least. Let's try to prove the point here. Object model. Imagine this: we have the invoice service and the shipping service. 2 super simplified examples, but you can imagine what can go into the shipping service or the invoicing service. This brings back memories. The largest class I've seen in my career, 35,000 lines of code, called invoice generator. 20% coverage. Good luck refactoring it. Invoicing. They broke it up. That's why I mentioned it. They broke it up in more than 100 classes. I know the guys. I mean, I shook hands with them. They are now in Nirvana. They have statues in the office. People, God or Aline, help me, please, refactor my own little class. You broke the 35,000 one. Right. Invoicing service, shipping service. And then we have a customer, the same customer, but this normally is doesn't look this easy. No. Let's make it more enterprise, right? Exactly. Now we're talking. But you can imagine a lot of fears. I don't want to break it. It's still morning. I want you to survive the day. So let's imagine this is large. And then you have these 2 little classes. Let me put them split screen to see both. Because something funny is going to happen. If you look in the left, a customer for G-invoicing has to have a name and a billing address, of course. In the right, customer for estimating shipping cost has to have a shipping address and some others. You see what happened, and also the name later here, you can see. So on one side, it has to have 2 attributes. On the other side, it has to have 3 others. The name is the same, but the shipping address is only here, and the billing address is only there. You see where I'm going? But now, with your mind, please multiply this with 20, and you get to a legacy system, right? Of course, there are shared things there, and these, to be honest, are also quite a few, right? Like this. And there you go. You have a data structure which has some core elements like name, phone, email, and then some things just for shipping, some things just for invoicing, some things just for preferences, right? And this is the definition of three bounded contexts colliding each other, stepping on each other. Okay? What invoicing is trying to do has nothing to do with what shipping is trying to do. Now, you knew that already. Let's be honest. You knew that already. You knew where you were. I don't have to tell you that the object model is going to be ugly. The code is ugly, not the object model. But the object model is going to look something like this. It's going to be large, constructing, where is it? Object model, yes, and then test data. It's going to have a lot of stuff just for the green part, a lot of stuff for the red part, different attributes for each area of code. What can you do when this happens? When you have an object model, like a class constructing test data for your tests, and it grows big because it wants to serve both shipping and invoicing, what could we do? Huh? The first little change to do would be to take the object model and cut the object model into invoicing test data, shipping test data, right? Now, we didn't make that much of a change in there, actually. We broke that large class to be specific for the bounded context they were talking about. But the real gain would be to take the customer object and break it into different pieces. Modules or microservices. We're allowed to dream, aren't we? I mean, like, and slowly, months, years, we crack it into pieces, right? So we first start with packages, then start with modules, then maybe if we have good arguments, we can go to microservices, right? So, but the object model is just one more pain in this game. We knew already what we should do, but object model is just one more push in the same direction. Right? I'm not going to demo this. It's too easy, right? I'm going to take the test data, I'm going to break it into, and you're going to see shipping test data, invoicing test data. Not dramatically complicated. Several weeks, many times in many companies I've seen this. They were unmarshalling JSONs from circuit test resources. So they have objects in their play so big that they have to read them from a JSON file. They were constructing their objects and firing those huge objects into their business logic. Now there are two possibilities here. You could be writing a not so smart application. How can I put it? Not to harm you. An application that is not very business logic intensive. I think it's more polite, more politically correct. On the other hand, you might be writing a loan approval workflow, like heavy business logic, 100 rules of. If you are on the not so super creepy smart business logic part, that's okay. Good work. If you have a lot of business logic, you don't want to write business logic on data structures that you don't control. And this leads us to the next design hint. Next design hint goes like this. Imagine you have complex logic that directly uses some external API. Imagine IRS. IRS in the US. I'm not sure what's the name for that in Belgium. I will tell you the name who hunts me in my country. It's called ANAF. It's the fiscal authority. Right? If you are calling, it's the best example. If you are calling ANAF the fiscal authority, their data structures are gonna kill you. The way you communicate with them is gonna kill you. They are using SOAP XML with client certificate and retries and response time of 1 minute. How the heck can you work with that in your business logic? Imagine the timers, the retries, the kind of problems that you... And not to mention the data structure they give you, like hundreds of fields. You don't want to write your business logic on such data structures. You're going to die. Right? Trying to test with those API call in the center of your business logic is gonna make your tests ugly, because your tests suddenly they will have to instantiate the ANAF result, right? Exactly, and allergy to ANAF result. I'm like, can you imagine how complicated the test would look? right? And you'll have to understand what the field called fname means, fn perhaps. What is fn? For historical reasons means first name. Right? Take that, right? That's one goal. The other thing that could happen is that you might be using a very invasive library. I'm not talking about an ORM. Invasive in the real sense. I mean, like, designed by some principals 10, 20 years ago. I'm going to show you an example in the code right now. If you're using some very weird library inside your business logic and you are mixing business logic with that library use, testing becomes cumbersome. In tests, you'll have to work again with the library, either mocking it or somehow asserting the effects that that library did. Basically, you are going to include that library into your tests on your business rules. Now, two games. In this part, with the not so super smart application, just gathering some data from 3 sources and sending to others, that's okay-ish. On that other part with loan approval, complex business rules, 200-300 business rules in the wiki, that's not safe, okay? That's not prudent, that's not safe. What should we do here? Come on, the golden standard, at least it was until recently, the golden standard for backend architectures. This time I want an answer. Do you know this? How? Sorry? The anti-corruption layer, exactly. And then the whole architecture is called how? Come on. It stings the eye when you cut it. Onion! Onion, thank you. You could have said onion, clean architecture, hexagonal or port adapters. They roughly go in the same direction, and with an anti-corruption layer to protect you against the evil that surrounds you. Thank you. So you will put an adapter on top of that garbage, and you're going to talk through the adapter, like the gloves you put to work with something dirty, right? So what you're going to do, you're going to call the API through your own class, and that class is going to give you back some object that is your object, your own domain model object, expressing what they gave you in your terms, using your names, using few fields, if possible immutable objects, and so on, right? Basically shielding your business logic from the complexity, from the ugliness of that interaction. The same for libraries in some cases. And that means that your tests will be able to be expressed in the same terms, within the same words and structures as your application. You're not going to gravitate, you're not going to be polluted with the API that you have to call, okay? And if we pull this example off, we're gonna, if we implement this, we can take a break. The break is after 1.5 hours, I forgot to tell you. So it's like in 20 minutes, more or less, we're gonna take a break of 10 or of 15 minutes at that point. So let's try this one. I'm not sure if you ever entered in contact, I really hope you didn't, with this. Anyone familiar with, anyone ever use this? Oh my God, this is the expert, like what, 30% of you? Oh, my condolences. This is the way to generate a PDF in Java, or in Excel, as a matter of fact. I'm using it for generating an Excel here. And let's see how this looks. This is just an example of an ugly library. You can pick your own example. But the point is, this code over here is polluted with shit. I mean, like, mind how you read it, right? With cells, with rows, with 4i. What the heck is 4i, right? And all sort of strange interaction with light orange, really. I mean, like, what is this, right? Solid foreground. And mixed with this library usage, you're gonna find scattered some business rules. This business rule. And that's really nasty, to find in some pile of code just the hidden gem, the business rule. What the heck is that? It shows you when the report puts an error on a given cell. When do you have the error? If the contract status is active and the last payment is later than 60 days ago, like 2 months, and if the remaining value of the loan contract is above a certain warning threshold. Reasonable business rules. And then, ladies and gentlemen, and then light orange. No, I'm not kidding. Look, warning style, light orange. You want to see the example? I bet you want to see the example. I mean, like, we also want to see what makes the business turns the world, don't we? You know, the most important programming language in the world, Excel. I'm not kidding you, folks. I made medical studies for a PhD in Excel. You can do that. You can do that. Statistics on steroids, don't worry. And that, in some occasions, it's like this. Oh, how cute. Good. And we are mixing some ugly library with business rule. Now, this refactoring won't be that easy. First thing we have to do is to cut out from this code I want to separate the interaction with this ugly library from the data structures and the business logic that I want to keep safe in my application. Now, as we can see, I'm passing contract in. Now, contract can be a very large object with a lot of stuff. First thing first, I don't want to pass such a big object to the export, perhaps. And more importantly, I want to put the business rule in the middle of that Excel generating logic. So I'm going to extract this first, and I'm going to say has warning, for example. I forgot to do something. Please excuse me. I forgot to show you the test. Not this. This is just too ugly. This one. The test. This test actually lets the export generate a file on the disk, and then picks the file from the disk, reads it, and allows you to see whether light orange. That again. Guess who's back? Light orange. Excellent. So the tests are ugly, you see? And why do I have to read get cell style, get fill foreground color, right? What if I have a bug right now and the boss is with the knife on my neck and I have a defect in production, people are losing money and I am reading get fill foreground color? Light orange. No. So let's be serious. The tests are ugly. That's my point, right? Now, what I'm going to do, I'm going to go to my contact service, and I'm going to try to separate my business logic from the formatting. Now, the has warning definitely is part of my business logic. I'm going to pull it up here. Right. Then you can see that I'm doing a try with resources, and then I'm doing a for. And the for goes on the contract. Well, I don't want to pass the full contracts to them. The first thing I want to find out is what exactly do they need out of my contract. I'm going to use an old refactoring technique called split phase in the refactoring manual cookbook. I'm going to separate the processing into computing the data, preparing the data for export, and then actually formatting the report. For that purpose, I want to identify what exactly is needed in this Excel reporting. I need to pass the number, the name, and the warning. Okay, so let's create a new class. I'm going to create the new class in the model, domain model. It's my own class. Okay? I'm going to make this a contract for export. 15 years ago, that would have been named contract view. Remember the days? But now it's contract for export or something like that, and that will contain the number, the name, and the boolean who has warning. Thank you. Good. Now, before I enter this madness, I want to construct over here a list of contracts for export. All right? Let's say contracts for exports equals. Yes, thank you. Good. Copilot. And then this contracts for export is what I want to use in here. All right? Like this. Just a second to alt enter this. Perfect. And then has warning. I don't want to compute. I will not compute has warning. It's right on that contract if it has a warning or not. And that's a number. Name. And that's I said number. Thank you. And then name. Perfect. Now, the part of code from here to bottom does not work with my contracts at all. I can actually extract this, the whole story, all of this out. And I can say, I don't know, export Excel, for example. Excel. Great. Great job. Now, Please notice that in the same class, I have two layers of abstraction. The high-level orchestration thing, saying, hey, I want to do this and then do that. And then garbage. No, not garbage. Shit. If you remember, if you know the video, I want a shit on my table. On my bed, I don't know. Right. So, forget about that. Sorry. Now, the point is that I want to cut away the part for exporting Excel. You cut it out, completely out. It's garbage out of my domain. Move out. What I'm going to do for this, I'm going to create an Excel, of course, exporter. What do you mean? And then this is a public. And I'm going to have to inject, let's pretend that will be a component or something. I can't possibly name it a service, can I? I'm disgusted to name it. It's a component. And then private service, private funnel, Excel exporter, thank you. And that Excel exporter dot export Excel. Excellent. 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 Am I the only one talking to the AI? Or probably no. What? You can't, anyway, doesn't matter. I apologize to AI. I think we're getting a bit, anyway. So this Excel exporter thing doesn't have to be here actually. And as a matter of fact, it doesn't have to be in my domain service at all. Why is it in my domain service? It should be in the infrastructure. All right, out, get out. Right, so because it's not really my business logic, it's just formatting a freaking Excel. This is not, right? Okay, and then what? Then what? Well, my contract service over here, right, I broke the test with this refactoring, for sure. I broke the test with this refactoring. Let's refactor the test. Arguably, refactoring the test is one of the most frustrating activities in our profession, especially if you do a large refactoring. Refactoring the unit doesn't feel like doing anything useful, does it? Like, damn it, you keep pushing and pushing okay. So let's see how this works. I want to go to my tests here. Right, where are you? My parcel, my contract service. I'm going to comment these out because it's really very hard to work with these. I'm going to just take the test and see how I re-implement the test. Again, one last look at this export before I comment it, about this test before I comment it. You see, I'm mixing both tests on the formatting and the presentation with tests on the business logic. The fact that name and number are there, maybe differently formatted, is not the same thing as testing whether some contract is marked as warning or not. I'm testing both my business rules and my presentation or my formatting in one go. That's bad. I'm mixing concerns. Single responsibility level at the test level, basically, right? Good. So I'm going to comment these tests, and I'm going to create a new one. All right. I'm going to create a new test. Let's see in the contract service. All right. Just for this method, let's try. Create new test. Contract service test. Yes. Good. Okay. I'm going to split the screen, and let's see what we need to write. Well, first things first, I want to call my friend, and then say I need to, well, this will be the dependency, right, that I need to inject somehow. So let's do this in a mock. Why not? I will put a mock in here saying Excel exporter, exactly, and then inject mocks into my contract service, exactly. Then when I'm calling the Excel exporter, export Excel, yes, exactly. Actually, not when, I don't need any reply from that. Excel exporter is the last thing I'm doing. So not a when, it's a verify. But let me first call first call the contract service dot export Excel, the export contracts of a contract. Good, right. And now again, let me copy from the old test. Let me copy from the old test how the contract looked. This, from here to here. All right, paste. So I'm constructing the contract. I'm putting the details in. Okay, all right. Yes, local date. Yes, and then minus days. What did I do wrong? I picked local date, minus days. What's wrong? Local datetime. Okay, now it should have been from the local datetime. Good. And I need this constant here. So the constant from the old thing, warning amount threshold, it goes here. Good. All right. And the amount over threshold also here. Good. Okay. List of. So I pass the export contract. Am I right to pass export contracts? It's a list of contract. Export contracts. What's wrong? Export contract. A contract. What do you mean string? Something is fishy. What does this get as a parameter? Gets a what? I think that's it. List of. Perfect. Good. And after I call the business logic, I'm gonna verify. That the Excel export has that the export Excel is called. So verify like this with Mockito that Excel exporter, yes, export Excel, right? And then I'm gonna take here out the export. Actually, I can really use a captor if I want. Captor, argument captor of the contract for export captor, which I'm gonna pass over here. If you don't know what captor is, you should know. You should find out. Go Google. How did you survive by now without it, really? But anyway, and then this, and I will just get the first time because I will pass a single contract, something like this. Good, and that's a contract that I need to assert. So I'm just going to check what's inside that contract. For example, I'm going to check that the contract number. Did I put the contract number? No, I didn't. Okay. Let's see. What am I testing here? Just the status. So look, let's do this. I'm going to copy from the old test all these, like this, into here. Let's see. All right. Right. Now, all of these tests here. For example, when I construct a contract, this is contract service. Good. When I construct a service over here, a contract, I pass the list of contract. Then I will not need to use some weird library to assert what was written in there. Instead, I'm going to use this. I'm going to capture the arguments passed to that adapter that sits on top of the library, and then I'm going to say the contract for export get the name is assert that is equal to the name above, and the same for the number. Okay, number. And that will be the first test. I will remove the part that had to do with the library and keep my own logic that checks just my own objects. Right. Then here, status, I'm gonna status, yes, active, right. Then now, again, the problem with local datetime. All right. And minus days 80, and then set remaining value. What's wrong here? Oh, it's one extra parenthesis, all right? And then if I want to check that this, instead of light orange, this probably is the best part, instead of light orange, I'm gonna say here, verify that my Excel exporter on the export Excel was called with an arg that the argument had the, on the element 0, because it's a list, had the warning. Because it had the warning, is equal to. The same thing here, but this time is not equal to, did not have the warning. Of course, you could write some little abstraction to simplify the test, but you see, it's not here, not there, without using any weird library out there, all right? And that should be the status in the contract. And this again, local date time now. Okay. So I am basically rewriting the test to don't use the library at all. I'm going to keep my business logic tested with tests that talk only in terms of my own object. I have a problem? Cannot invoke double value? Yes, I forgot to do something. I forgot in my rewrite, in my extraction of the business logic here, I forgot to pass the warning threshold. So somewhere in the before, I have to do the Excel exporter dot, not Excel exporter, but the contract service that I'm testing, warning threshold equals warning amount threshold. Done. So there. Okay, the tests are green on my business logic. It's and then I will test separately the stuff that it really writes the export in the file. Okay, the export. Good. Now let's run all the tests to see if we're good. And just when we wanted to take the break, we have an architecture violation. What is that, you could ask? And then, in practice, you look behind, and there's no one behind. You look the other side, no one that either. What test? Now, I'm not sure if you guys heard by now by the thing called Arc unit. It's a framework that can. Who has heard of Arc unit? Arc unit. Whoa! That's like 60%, 70% of you. Amazing. So you can put boundaries into your code base with this tool. You can check that some packages don't depend on others. Excellent. Excellent. And some teams actually started using those instead of creating 7 multi-Maven projects, multi-Maven module projects, to put boundaries around the things they want to protect. Good. And they run on Jenkins. Now, the boundary that I'm breaking over here is that the domain should not have anything to do with the infrastructure, which is the definition of the onion architecture, or the agnostic domain. The domain should not know about the infrastructure. To fix it, I'll just go to the Excel exporter, extract an interface, call it, let's say, a contract exporter. I don't really care if it's Excel for now. I'm going to export the Excel, put it in the interface, and then I have the interface, which is implemented by the class. What should I do next to fix the architecture test? To take it from here and put it where? In the service, in the domain service. Perfect. And now the domain has nothing to do with the infrastructure. The infrastructure knows of the whole domain. The domain knows nothing about the toilet, the infrastructure. Okay? So, all right. What that meant is that we put adapters on top of some ugly library, and that was not a simple example. That was a really complex one. We introduced a new data structure. We created an adapter that protected my logic from knowing about the Excel generation library and that ugliness, right? Okay, I just noticed that my words are being live translated. Lied. Perfect. Thank you, AI. Good. What was that? Fun. So the onion architecture, briefly here, the idea is to keep your domain in such a way that you don't know about the external world. Whoever calls your application, those structures should not enter the domain. What other application you call, you should not be aware of their quirks and weirdness, right? And if you're using some library and someday you could wrap an adapter on top of it so that, again, you are protected from the garbage, from the way of seeing the world in Apache Poi, in that library that we've seen. Good. So what did, basically, that allows you to keep your core business logic protected, both expressed and tested with the words of your own domain, with what you control, with your structures. So what we've seen by now, we've seen as a bit of a summary. We started saying that unit testing are probably giving us a lot of feedback about how the design needs to be improved, especially valuable if we keep adding logic without stopping and reflecting about where our architecture is going, right? We mentioned the rules of simple design from Kent Beck. Then we said that when you start mocking stuff, and mocks are not only honey and butterflies and unicorns. Mocks can harm you if you mock each class in isolation without considering their responsibilities. Then we introduce the concept of a social unit test, a test that includes more concrete classes and surrounded by the mocks as a component with a well-defined responsibility. And then we discussed about the object mother and passing less arguments to the object, to the methods we are testing, to have simpler tests also. And we ended up with talking about onion architecture, in which we saw how tests get simplified by removing the connection to the external library or API from our code, especially if my application has a lot of complexity to implement, and especially if that thing that I'm trying to protect is ugly, like a very old library or a very annoying API that I have to call, the IRS, for example. All right? And with that, I think we all deserve a break. After that, we're going to see how tests help us to simplify complexity in both vertical, horizontal, and then functional programming in the wise of testing. Okay, 15 minutes break. I'm going to put a little timer on the screen just to be sure. It's like almost 5 past 11, right? 11 or 10? 11. 11. All right. All right. So you're back. Wow. Highly complex logic. Let's see next how tests allow us to feel when complexity has accumulated too much and find ways on how to break it into smaller pieces. Probably that's one of the most important, the most challenging parts of our profession, right? Keeping up with the complexity that keeps accumulating. And again, tests could be a way out of it. Let's see how. This famous quote, any problem in computer science can be solved by introducing another layer of abstraction. What does that mean? It comes from the time of the TCP/IP stack. No? They have the application, the transport, the network level. So the idea is that any complex problem you are facing, you could always try to introduce new simplifications of parts of the problem to come up with some elegant solution to be able to grasp the complexity. Abstraction over here does not mean abstract keyword or interface. No, it has nothing to do with that. It has to do with simplification of reality. It has to do with a class doing for me some stuff so that I don't have to be aware of the details. Okay? All right, so let's see how tests help us in this sense. Let's imagine for a second that there is a class called big service, which has inside, because it's big, a lot of functions. And those functions grew complex. We have f, which grew complex. When I say complex, I mean you need at least 7 tests to have a number to drive through that method to be able to check what it does. And f calls g. G is also complex. And imagine you've wrote both these functions, f and g, in the same development effort, in the same sprint, for example, right? And then in f, you call g. Both are complex, but because g is so complex, you don't want to test both together, and you think of testing g alone. What do you mean testing g alone? I mean testing g directly. As you will see in the code example, this can raise some issues because G might have been private. Ooh, encapsulation. Let's see what we do about that. But imagine that G is now fully tested. If G is fully tested, you're going to turn your test to F. And you're going to fire your tests against the F function, the public function. Now, when your tests are going to enter F, we're going to enter G, and then G might break for weird reasons. But that might feel unfair because you've already tested G, haven't we? So here goes the idea. Can I somehow test only what F is doing without letting F enter G? Okay, I think I've said F and G 20 times, sorry. Can I somehow test the high-level function without it running the low-level function within the same class? In other words, can I mock a local method call? And if you ask this on ChatGPT or Google, they will be kind to you and they will tell you about the spy. The partial mocks, as they are called, is when you have a class and in that class you cut out one of the methods. But you don't cut out the whole class, you just fake some methods in that class. Some methods will be real, other methods will be mocked. It's extremely evil and it's famously bad to do partial mocks. As a matter of fact, I'm going to tolerate those only if you are approaching some legacy code and you want to test it. The problem is that years later, when you're going to come to a test, actually, let's jump to code, but to state just this sentence, it will be very hard later to understand when looking at the failed test, what method in production is real and what is mocked. It's very easy to lose control about what method is really executing and what method is a mocked one. Let's see the code next. And then we'll work it out together. And at the end, you're going to see, I'm curious if you figure out where this is going. Let's see. So here, spy, big service, right? And I'm going to do exactly like I told you. But again, to keep code on the slide, on a single slide, I couldn't possibly put here like terrible business logic. I've just put two conditions. One is there in the low function. This is like the G in our slide. And this is the F function, the high-level function. And imagine G grew so complex, required so many tests that I want to test it alone. But how the hell do I test low alone because it's private? How about encapsulation? First things first, you look behind. There is no one behind. And then say, what encapsulation? And then, because life is hard, hashtag. You create a test, right? For the low-level method there, I'll put it in the right, and you will start working our way. Okay, let's see. So, I want to say if I instantiate big service, and if I call a low, if I pass an order which is before minus months 1 month ago, okay, let's do this. I'm going to say local, let me double check if this is local date or local date. Good. Now, minus months 2, so this is let's say long ago. Huh? Poetic, huh? Long ago. Long ago, and then there will be an order, a new order, please, thank you, dot set creation date long ago. This is almost Shakespeare, long ago, like beautiful. And then low, I'm going to pass the order. If I'm passing an order which is created long ago, that big service low should break, should throw. Let's check that. Should throw the exception in the left, right? The illegal argument exception. So yes, but that's the exception I am expecting. So assert that thrown by, good. Assertions from assert J, and then just one thing, breaking news, folks. No one ever uses assertions from from Jupyter anymore, right? We all use assertions from assert that. Okay, I mean like no one in the last year I've seen using the assertions from Jupyter, only assert J. And I'm doing every week with different companies. So assertions.assert that thrown by, I pass a lambda, and I expect that this code over here is instance of throw illegal argument exception, right, dot class, and with the message order to low. Is it exactly that? To old. Ah, thank you. Run. That should go green. Amazing. I've tested the low-level function, and I want you to realize where we are. I'm going to add +7 more tests. Pretend. Imagine you're going to, right? Because it's a complex logic in the left side. So I will have to take this test and make much more like this. All right. Good. So I'm happy. I'm done. One question is, see if I get the answer from you folks. What should I put here? Visible for testing. So you are also a sinner, isn't it? Visible for testing. What does that mean? You will see later today in the last example a very good practice to use this. here it's a bit dubious, but what's the purpose of this annotation is for automatic code scanners to detect. Basically, I'm basically saying that I am deliberately breaking encapsulation for tests only. But no other production class should call this function. So what does that mean? It means that if another class in production tries to, in the circle main, right, tries to call the same function, all the sonar tools I know are gonna blow up saying, hey, is that a call to a visible for testing method? You should not be. Actually, it has an issue right now. IntelliJ also go, hey, test only method is called in production code. What are you doing? You aren't supposed to be doing that, right? So I'm breaking encapsulation, but I'm breaking encapsulation deliberately just for testing, right? And I've tested it. Congratulations, right? But then you turn your attention to the other function. And this is where it starts to get nasty. Look, if you want to test the other function, let's write a naive test for that. I'm going to commit proudly this, proud test, for the low method. By the way, all that we do here is committed on a Git. You can, not that it's some rocket science, but if you want to do the exercises again with your teams or whatever, you can find it on the GitHub. And I've posted on social media the slides with the link inside. So here, let's test the function hi. Let's do this. I'm going to do a test for the hi method. To test the hi method, of course, I need to instantiate big service and to call the hi method. And I will need an order also. This order over here is going to be an order that would have to have a payment type equals to card. So a set payment type equal to card. Good. And in that case, the result will be bonus. So this will be the result. And the result, thank you. And result dot assert that, no one uses anymore the assertions from Jupyter, is equal to bonus. Thank you. Good. Now, another test like that to cover for the regular, you can imagine. But I won't write it, use your imagination. Right? And I will just write here plus 5 more tests like this. And I will be super proud of my test. I'm going to say, yeah, let's run it. I'm going to run the test. And the test is going to go failed. Saying null pointer exception, but null pointer exception not in my method. Null pointer exception here. Let me just, here. Line number 33, right? So my tests on F, on the high-level function, blow up because it dared to call the other low-level function. Is it fair? I mean, like, what are the options here? Literally, there are 2 options. One option would be to go here in the order and say, you know what, I have to put, I mean, like, first course a bit, and then set creation date, some date, because otherwise it's going to blow with null pointer exception, you son on the beach. But, and you can imagine this can get much more complicated because that thing uses not only creation date, but yeehaw. And next thing you know, object mother. Object mother, test data, give me a customer, like big bang, what's the order? There are other ways, because this is a bit unfair for the tests on the high function. And imagine doing that 5 times. That's the problem. In this section, in this half, we're going to look at code which is very complex. Code very complex requires a lot of tests. A lot of tests will exacerbate the pain of writing these over and over and over again. So this is a fair solution. More, let's say, social. Can I say that? More social? How good to see you again, folks. Anyway, more social. Good. And then let's look at the other solution. The other solution is to turn to dark magic. And to say, this order over here, no. I'm not just going to use the big service. The big service is not going to be a big service instantiated cleanly, but let's call my friend Makito. This is going to be a spy. There are 2 ways to do it. Let's use the annotation spy, right? Now, the alternative is to say spy, but I'm not supposed to teach you here the framework. The framework, it's about design. So I'm using a spy. If you are using a spy, you can tell the spy, you know what, big service, when, please, do nothing. Do nothing when that big service is called the method low. Do nothing with any object. I don't care. Just block. Don't do anything smart. Just sit there doing nothing. And that, putting this line here allows me to remove this line. Understand? Because I don't need to fill all the data needed by the low function in order to call the high function. The high function would now not, when the call happens here to low, the high function is going to stop, it's going to do nothing, and then continue doing the rest. So you see, I've removed the creation date, and the test is passing. Okay? So this is a partial mock. Partial mock can, let's say, block a local method call. Do not use this unless, do not use this unless to attack legacy untested code. Attack legacy untested code. If you have a greenfield new project that you are really fond of, that you really love, don't do this. Okay? But do what instead? Imagine a lot of tests on the high, a lot of tests on the low. What's the point? The point is, partial mocks will make your tests much harder to maintain on the long run. The alternative would be to go to the class on the left and ask, are you by any chance doing things at different level of abstraction? What do you mean? Are you this F, by any chance, sort of a facade or an orchestrator, like a high-level policy? And could G, by any chance, be a simple function to send an email, to send an SMS, to do something very well-defined and small? If that's the case, you could separate the class by layers of abstraction in two classes, high-level depending on low-level. Make sense? If both are... The tricky part, I'll tell you, the tricky part is that you might not be able to find a good name for the low-level class. That's the dark secret here. Naming this class can be extremely hard. In some occasions, it's trivial, like notification service, email service, Kafka sender, something. Many cases, it's easy. But other times, when you are talking about some complex business rules, it's hard to name that. You can't, and if you can't name it, it means you did not identify what that class is doing. So you need to think responsibility principle, name it first. Good. So let's imagine that we found a good name. How will the code transform in that case? Well, the big service is going to remain like an application service, if you want, the high-level policy, the entry class, delegating work to the subsequent smaller low-level classes. So I'm going to end the class here. I'm going to create here a low service, let's say. The names are deliberately silly, just to highlight the need for good names. Right? Public. No more need for visible for testing tricks. It will be a full-fledged public class. Right? And if I want to call that low service from the big service, I'm going to have to inject over here a low service. Like here, let's call it low, right? So it will turn the class above into a sort of an application service, right? Good. Now, how do the tests change? Instead of using a spy over here, basically the tests are going to be broken into two also. I'm going to have a low test, and the big service test is going to have to inject mocks, the mock of a low service, right? And whenever low is called, it will by default do nothing anyway. So mocks, if you don't program them, do nothing anyway. So this call is just going to do nothing. Sit there, absolutely nothing. And then low test here is just going to I'm just going to instantiate over here the low service. Right? This could be a domain service. The other one could be an application service, if you want to use more fancy terms. Right? One would be the orchestrator, one would be the low-level detail. Okay. Tests. Let's see if the tests pass. Yes, two green tests, each with its own, so full-fledged public, and depending on each other, right? So basically, you acknowledge the fact that one of the classes is doing coordination logic or the entry point logic, and the other is just taking care of a detail. Whatever that detail is. Could be sending some notification, could be handling an error, could be doing some retries, could be anything you can imagine, okay? If it's complex enough to require, I don't know, 7, 10, 13 tests, you should consider creating a separate class. Consider, not always. These are only hints, like clean separation of low versus high level. These are only hints. No one forces you to do these changes. These are just, you should understand what tests are saying and agree or not with them, right? Hey, it makes sense to break this class out. No, it doesn't make sense to break the class yet, perhaps. So that's what I also said in the slide here. If splitting the class breaks the cohesion of your flow, if you feel you're spreading too much of the logic, you might keep the logic in one place and instead social unit test it all. That means to go that path and say, create an order, set a creation date, even if I don't really need the creation date for my test. And 2 days later, object mother, to create a standard order that you tweak for your case. Okay, that's the other path here. You break or you test as a whole. You then test half of the work in there. Make sense? What was saying here? Right? Partial mocks are usually a code smell. Right. And this shows us how to split code by layers of abstraction, like place order and process payment, if you want another example. Good. Now, let's see how tests also hint us on how to break complexity, not horizontal in high level, low level, but vertically. Let's see the next example. Vertically. Slide first. Imagine a class. I will tell you the name of the class for extra fun. It is called, ladies and gentlemen, product service. A class named product service in a product microservice, a class named product service is going to manifest this problem. You're going to find in the same product service a lot of dependencies and a lot of functions, each function using a different subset of the dependencies. Some of the functions are going to use A, other functions are going to use B, and so on. You see, each entry point would use a different set of dependency. Right. Now, if you try to unit test this class, you're going to, using the standard copy-paste from here to here and mock in front, you're going to have mock of A and B. This is better played in the code, to be honest. And because also the code is in here, the domain is very, very, very interesting. We are baking shawarma over here. You know what shawarma is? Excellent. The high quality, very nutritious food. You can live many years if you eat only shawarma. Good. Make shawarma. And this shawarma over here, and then tzatziki. We are basically two, right, in a fast food service. We have two entry points. Now, to make a shawarma, I would need the onion. At least in my country. To make a tzatziki, I will need cucumbers. And I'm not talking about the BDD framework, I'm talking about cucumbers, the green cucumbers. Right? Okay. So, is cucumber allowed? Then make tzatziki if I'm out of cucumbers, exception to the client. Out of cucumbers. Impossible. Right? The same here. Hey, do I have onion? No, exception. In my country, if you eat shawarma without onion, anyway. So the point is, there are some guards, some checks, right, at the beginning of a function. Shawarma requires this, tzatziki requires cucumber. Let's see how the tests look. I'm going to zoom out this, and I'm going to focus now on the test, here. The test reads like this. You have, of course, extends with Mockito, and then mock, and then inject mocks. And we have a shawarma test. Notice that to enter this function, I want to have onion returning true. Because if I return false, I'm going to throw exception. Okay? So I have to program onion to return true. And then some other flags. The same for tzatziki. I have to have cucumber and I have to have onion. All good until here? Right? We have to understand the code first. Now, What's going to happen if I have to write a lot of tests on the shawarma flow? Let's try. 1, 2, 3. Let's just put 3 of them. The rule of 3. Right? 1, 2, 3. 3 tests, each doing these lines. There was a principle in 3 letters that says this is bad. Right? Don't repeat yourself, exactly. We are repeating logic in a test. It's bad. So what can we do? Well, it's easy. It's easy. Everyone knows you can put it to the before. Of course. Anything that repeats between different tests, you can put into the before. All right? And I'm going to put that here and here. All good. Fun. Simple. Makes sense, right? We have 3 tests sharing the same initialization. That initialization is going to go in the before to be shared between the 3 tests. All good. But the same happens with tzatziki. Of course. I'm going to have all these tests with tzatziki also having to have cucumber required returning true. Because this. So now I have this line again 3 times. Don't repeat yourself. I'm going to pull this up into the before each. All good? I'm not doing anything fancy. I'm just showing you what can happen. Very, very easy. Right? Completely reasonable. And I'm going to put it there. What's going to happen if I run my test class now? It will complain, it's called unnecessary stubbing exception. It will complain that some of the stubbing in the before each are not used by some of the tests. Unnecessary stubbing, and this is Mockito teaching us how to write clean and maintainable test code. That you should not have in one test some stubbing that you did not use. The fun thing is that this changed from Mockito 1 to Mockito 2. They broke their behavior. And now if you're using extend with and mock, if you do is onion allowed, let me make sure you understood exactly what happens. Before each runs before every test, right? So it's some people call this a fixture. Test fixture, the setup, the shared setup between all the tests. Now, imagine that you are running shawarma test. This would run, and in this, there will be the is cucumber allowed. This line there will be when dependency is cucumber. Then this test is going to run, and while running this test in the shawarma, there will be no usage of the cucumber allowed function. Make sense what I'm saying? You are programming a stub that is never used from your production code. What to do about this? Use lenient, of course. I mean, like, it's too easy. Can I ask ChatGPT? I won't there. You are not here. But if you were in a group, I'm going to try to ask. ChatGPT is going to answer. Of course. Use strictness. Mockito option settings. Strictness equals lenient. And you're good to go. You're back in Mockito 1.0. Shawarma. That's exactly how your before is going to look 3 years from now. Shawarma. Because anyone having to put a test in this test class is going to shovel more expectations, data initialization, take that, and then 1 year later, when one test is going to blow up, you're going to look here and say to yourself, what the heck am I using from all this before, right? It's not good. No, because then it will hurt your liver. You know why? Because you're gonna start drinking. That's not fun at all. Not fun for your health, for your children. It's not good. Well, if for your cat, it's not good. Is onion allowed? Is active? Is cucumber? So what do we do? That is basically reverting time to Mockito 1.0 when this used to work. But they changed it just because they noticed what garbage we were writing in our tests. Okay? Good. So don't do this. Don't. I'm going to commit this still. Lenient. Can I say for the lose? No. Probably. No, I don't know what that is. But anyway. So don't do this. Don't do this, please. Don't do this. Don't do this. However, there is an exception to this rule, like any rule. Don't do this unless there is a situation with feature flags. Feature flags, functions which are completely side effect free, which are just telling you true or false, we have the feature enabled or not, and that this if might occur under another if, in some complex logic. If this happens, you might or you might not get to check the feature flags. You see my point? You might or you might not get to check the feature flags, but you want to check. You want to go through this function. Let me put the. I'm gonna just simulate a lot of complexity, right? You want to go there and there and there and there and then there and then more there. Whether or not you checked with the feature flag or true or false should not break your. So I'm talking about some very simple side effect free, which is just bringing some data like a feature flag. For these situations, I have another trick for you. It's called a lenient, selective lenient for a certain stubbing. One stubbing which is not critical. I can close one eye, not both, one eye. Okay, you could or could not be called. I don't care about that because I want the whole class to behave like we have pork shawarma. I don't know. I don't really like that, so let's put it on false. You get the point, right? You get the point. All right. But what should you do? What should you do? So this is what I'm demonstrating here, is that selective lenient for some stubbing, right? But what is this trying to tell you? When you have a before, initializing some mocks, some state, used by multiple tests in the same test class, I explained that this is going to make your test hard to maintain on the long run. And that's why Mockito would throw exception to you, okay? What should I do here? What? Split it, of course. It's shouting at me, let me out. Cut me into pieces. That's exactly what you need to do. To take this fast food test and make separate one for tzatziki, separate one for shawarma. On the one with tzatziki, we're going to call it, of course, tzatziki test. All right, good. I don't need the feature flags, as you can see. Okay. And the other one was going to be the, did I left the tzatziki? Yes. And the other one was going to be the shawarma test. Separate test classes. Shawarma test. All right? Good. The one with shawarma doesn't require cucumbers. The one here stops the cucumber. The other one there requires just onion. So that should pass. Separate test classes. There, you see? Separate. It has a very fancy name. It's called test fixture. Test fixture is the setup, which is shared, right? Test fixture, test breakdown, or breakdown. Because the before got ugly, you break out stuff. You want to ask something, or? Inner test classes are going to end up with a file of 500 plus in practice. If you put classes, like you mean nested classes, nested test classes. And unfortunately, the Java language is not really prepared for this feature. You can't, for example, add more code to a class from another file. In short, that file with nested classes is going to grow very large. Nice trick, but not exactly for this scenario. There are some other places. You know where you use nested classes? Imagine a very long flow that has many, let's say, decision points in which case you can take different paths, right? And you can drive one test this path, and when you reach this point, you create your parent test class, and then you pile on that a nested test class to explore this part of the checkout flow. And then you continue with this test. Let's put it in green. Basically, I'm talking about hierarchical test fixtures. The annotation at nested in JUnit 5 that allows you to build upon the fixture you've already constructed. But that is useful not when you have unrelated flows, shawarma and tzatziki, but when you have a very long flow, the checkout flow, that 100, 300 lines later splits in two directions. The checkout for a corporate, for a juridic person, for a physical person. In that case, you can do the checkout until that point with the base test class, and then fork for the corporate or for the physical person. But it's on the same path. What I was showing here does not apply because it's unrelated entry point, shawarma and tzatziki. They don't have anything to do with each other. But wait a second, what did I just say? They don't have anything to do with each other. So what we did already, we broke the test classes. Congratulations, we are, and while we have the saw in our hand, we look in production and we say, and we can break the production code. What? Break the production code just because I brought the test class? Why not? Unrelated flows living in the same class. Let's put a more realistic class name here. Product. The product service, right? That has so many flows. Do that. This came from the onion or layered architecture to have a layer for business logic. And in that layer of business logic, put everything. Even if it's unrelated to each other. I wrote application like that for a decade, right? That doesn't quite go well with testing because then you have these problems. What do I mock in the before? So, what do you take out of this? I don't want you can't possibly break a production code whenever you feel like breaking the test class. But if in a large product service class, you find one or two flows that are taking 30% each of your test class, let's draw because it's visual, it's more like, this is a test class. These are some tests for a flow, these are some tests for other flows, for the fourth flow, and then comes this flow, you know? And then of course this flow, and then this flow, and those heavyweight flows over there, they might deserve a separate test class and then a separate production class. So I'm not a big fan of creating a service for every single flow, but if you have a very heavy flow, think. This is what tests are telling you. Think, hey, they deserve testing alone. Don't they deserve their own class? And you break the production class. This arguably could be the most important part of this discussion. When a service grows too wide with many entry points, not in the first second, not the moment you see, there is that extreme of people that don't tolerate two public functions in the same class. What? Two public functions and they say, wrong! I'm not that guy. No. But if you see in a class some of the entry points taking up 30% of the logic, and the class exceeded 200 lines, 150, 120, it's time, right? If tests are already making noise, trying to reuse and firing 20 tests on the same public method in that class, it's time. It's time to take the tests and that part of the production code and rip it off, right? And with dependency injection, that's a piece of cake. All right. Done. 30 seconds. Right? 30 seconds now, 1.5 years later. Remember 35,000 class? 1.5 years they worked. Okay, it's not fair because that was not on a dependency injection framework. That was a swing application. Swing. And it's not a swing, it's swing. Not fair. The comparison is not fair. We don't write today code with the mindset of C++ like they wrote that class. It's 15 years old code base. Not really relevant for many of you today, for many projects today. But the point should stand, should be clear that if some part of a production code requires dedicated test class, that's a sign you might want to break it out and cut it into pieces. Okay? So that's horizontal splitting. What does that mean? Horizontal splitting means you break the class in two unrelated classes on the same level of abstraction. Same level. Neither one calls the other. They are equal. rights. Socialism. Yeah. No, wrong. Wrong. No, and you fail. Epic fail. Okay. The point is, the point is, unrelated flows. What? Unrelated flows. Yes, people that are more equal than others. Okay, unrelated flows that should stay in their own class, right? When they grew, right? Now, this can lead to a very wild architecture, like Jamie Bogart suggested. Anyone heard of vertical slice architecture, VSA? Vertical slice architecture. Only 5 or 6 hands, but I bet many of you are doing it. It's the idea of putting the whole of a use case in its own class. Screw layers. Let's orient code by the endpoints we exposed. No more domain, application, service, nothing. Just independent classes, one for get product, one for create product. And you will see a single HTTP endpoint. This is quite nice for microservices, to be honest. Yeah? So you orient the code not with layers, but you orient the code by what the feature is doing. And the dark secret in this architecture, which is the alternative to Onion, is basically to put here inside even repositories, for Christ's sake. Anything to suit your need. But no more than a single endpoint. It's wild. Don't go back home and tell your architect, Victor said that. Don't. I'm going to get a phone call. I don't want that phone call. It's a bit of an anarchy at first. But it goes in this idea because each flow has its own class, right? You don't have layers calling layers. Just makes sense? Okay? Hey, give it a read. It's interesting. I bet more of you do it without knowing. Maybe without naming it like that. Right? So tests help us to break complexity vertically, meaning high level, low level. Horizontally, meaning unrelated complexity with unrelated complexity. Break them apart. And also, every time looking at the roles. Can I name the class? Can I name tzatziki service? Tzatziki service. I did not do the tzatziki service. It's a beautiful, beautiful, beautiful name. Tzatziki service. Its own class, make tzatziki. Only that logic alone. And the other one is called now shawarma service. By the flow inside. Right. Good. Let's see the tests, how they change. The shawarma test, of course, is going to target the shawarma service. Fun. And the tzatziki test is going to target tzatziki service. The names are not entirely clean. I could clean it, but my mouse keeps pulling down. I can't really type very well on this, sorry. But you get the point. So, broke production. Because tests. Right? Okay. Nice. Quick brainstorm here. Normally I would have liked to do a round of table to see what you think, but this time, it's not doable, so I'm going to just shout out and wait for you to catch me by the corner when I exit with an axe and tell, no, you were wrong. Let me see. Repository, right? The one with Spring Data. No matter what technology behind, right? The one with Spring Data. Should I mock it? Well, it is a very stable interface that doesn't change often, of course. And it's very painful if you want to play it for real, because you would need a memory database to start up. Right? Does it have a clear responsibility? Yes, it does. Mock it. Not a problem, really. Message sender. Sending on a Rabbit template. The problem is the idea is that message sender responsibility is very sharp, very clear. If you're going to send a message, no argue about it. Just doing that. It's a simple API, clear responsibility, and again, expensive to integration test. So mock it. REST template. Have you ever considered mocking REST template or web client? Are you alive? Wow. REST template and web client, if you want to mock it, you would see, because it has a fluent API, you have to return back the same mock. It's extremely complicated to mock that, because it's made in a way which is very convenient for the user. Not to mention the number of parameters you can give it and the overloads it has, it's extremely complicated. So instead of mocking it, you could consider either raising a wire mock and firing the request for real into a wire mock in an integration test, or adapt it. What? You don't use REST template and web client in the middle of your business logic. You take that garbage and that sheet out, put it in an adapter, wrap it nicely, and the adapter on top just returns you what you need. And you mock the adapter. That's much better, because it allows you to clean also the domain logic. You will not see REST template and API details, data structures, or authorization retries in your business logic. They will be hidden from you. Satellite, like a mapper. It's too easy most of the time. It's too simple most of the time to allow to deserve its own test and then be mocked away. What does that mean? It means I want you to just integration or flow or social test the whole story. With one single go through the mapper, you've covered it. So if you pass one test through the, depending on how many branches it has inside, but test it with someone else. A service. If that service has a clear, well-defined responsibility, go ahead and mock it, but review that first. Right? For example, notification service is a good name. Update product stock service is a good name. Right? Focused on doing one single thing. If they have a very unclear role, like product service doing anything, think twice. I mean, like, at least review the APIs, the methods you're calling in the product service. Right? A DTO, don't. So data structures should not be mocked. Parentheses, unless aggregate design in domain-driven. Anyone using aggregates in their day-to-day life? Aggregates. Look around you. You are 10 in what, 200 people? Few. But if you are using it, you could find huge logic in your data structure, in your aggregate. In that case, you could think of mocking it also. Good. Now, last half an hour, if I'm not mistaken. Yes, almost. How unit testing promotes functional programming values. Now, it's important to understand, functional programming unit testing doesn't really care how you implement your logic, if you're using streams or for. But unit tests do care if you follow the values of functional programming, which is pure functions and immutable objects. Now, before we proceed, we need to define what pure functions are. Pure functions are not allowed to do any side effects. I should have asked first. Who of you here knows already what pure functions are? That's like 80% of you, 70% of you. Fun. I love to see that. Pure functions are not allowed to change anything, not allowed to send and insert a message on a queue, post, nothing, not even a setter. Nothing changes in the world. So they just compute a value, and the value they return, it is the same given the same inputs. That means it's not allowed to draw information from other sources than the parameters. You won't see a pure function doing a get or a select or using time and random. Or if you do that, you are not pure. Okay? So pure functions. And why do we care, you could think? What's the connection? What's the relationship? You'll see next. Let's see. Let's go to the code. This will be the last coding example. It's a bit more complicated, I warn you. But I'm supposed it's the last one. After that, you can go eat, relax. Let me drive it through the code, and then we're going to see how it's tested. And then we're going to refactor this. The goal of the refactoring would be to isolate inside a pure function. Let me maybe motivate this a bit. We will look at some code that does networking, that does retrieve from the repository, calls over APIs, right? And mixed with these external dependencies, there will be heavy logic, complexity, heavy complexity, requiring dozens of tests. I mean, 10 tests, for example. Now, if you look at this code over here, you're going to need 5 mocks. 1, 2, 3, 4, 5. 5 mocks. If I tell you that inside here there is a lot of complexity that requires, I don't know, 15 tests, That would mean that in 15 tests, you're going to be playing with 5 mocks. That's not fun. Just multiply this number. How many tests, how many branches, or how many tests, and how many mocks do I involve? You shouldn't get above, I don't know, 10 or 20. If you play too many mocks and too many branches in some code base, you need to do something about it. What would I do in the code with you next? I'm going to take the complexity inside here and pull it out in a separate function. And I'm going to strive to make that function pure. A pure function, by the definition, will going to give me a result, the same result based on the inputs. And I want to put all my complexity inside this function. Because unit testing it will be a piece of cake. I won't need any mocks. Because a pure function does not bring data from other sources, only from its parameters. So everything I will ever need is in here, A, B, C. I won't have to do any network call outside. Therefore, no mocks. Let's see if we are able to do that. So this is the code. I told you this is not the easiest code you could see. Let's walk through it slowly. First of all, a customer ID. Nothing happens if you don't have a customer. So you could write your beautiful startup. If you don't have a customer, it won't work. Okay. List of product IDs, which are the products which the customer wants to buy. Then imagine you have some prices already available inside your system, some sort of a cache, if you want, like my own prices, for example, for those products. Good. The first thing that they do in here is to fetch the customer by ID from some data store. If it's GPA, Mongo, Redis, Cassandra, I don't care. Then get the products, the same. Get them all by their IDs. Good. And then I'm going to hit an enter. Ever found in legacy code a suspicious empty line that saved you 2 hours of reading? Because of that empty line, you got it? That thing above doesn't have anything to do with that thing below, that empty line, gold. Right. And then this. To be able to grasp it, I'm going to hide some part of it from you and see what goes on in here. I have a list of coupons. I have a map of final prices. List of empty collections before empty collections right above a 4. This is already a code smell. Empty collections defined above a 4. What do you think is going to happen in the 4? They're going to be filled in the 4. All right? That's not very functional programming-ish, if you want. Let's see what happens next. We iterate through all the products, and we check the product ID to see whether I have the prices already in my internal prices. If I do, I'm good to go. If I don't, I have to call network. That's a network call. Repo, and now network. Then here, the mystery that I will show you later. And then at the end, mark use coupons. One more message on the queue, perhaps. Okay. This means 4 mocks. Next exercise. How many tests do you think we need to cover the logic in front of you? How do you count? 8. Ooh la. Let's see. 8. Let me take my chance. 8. I need to see how you counted so many. Let's see. I will write a test going up to here. Maybe not entering the 4. But before writing this test, I'm gonna call the business for a second. Your business, does it have any sense for them to compute prices for no products? How did they ever get to that phase? And they're going to tell me, no, it's impossible. You can't check out unless you have some products in the cart. Oh, thank you. So this test is not reasonable for business. It doesn't make any sense for business. If you think about this method as a bubble of its own, as your universe, you will not know this. If you take your head out of the box and you look around at the big picture, you could find that it's not possible to get here because a validation will fail previously before ever entering the method. You see my point? The bigger picture you see, the more absurd cases you can detect and not test. Doesn't make any sense to test with empty list. Nah. What other test? Well, I will need to test that goes into the for sure. Maybe not entering the if, right there, and then go there. That's one test. I will I will ignore this part. The next test I'm going to write is going to enter the if, for sure. All right? And perhaps you could engineer one more test for the find by ID, although I seriously doubt the benefit of testing this will not find the customer. Is it something I want? Is this business relevant? The discussion can go on and on. Maybe two. I'm curious how you get to it. I want to see. Perhaps I'm missing something myself. Perhaps 3, 4. Okay, 4. 2, wait, 4. 4. Let's stick with 4. 4 tests with 4 mocks, good to go. We're okay. But, remember, 4 mocks, yes? We will involve 4 mocks in this code. However, here, what's in here? In here, imagine dragons in here. And there are, indeed, dragons. Let's see how many tests would you write for the part of code in front of you? Have you gone to fingers from your... How do you count? Well, definitely you want a test that enters the if, one that doesn't. Wait. It doesn't for what reason? There are 5 reasons or 6 for which it could turn false to that condition. So, I don't know, 6, 7? I'm curious, how many tests would you count? Like 15? There are, if you really played the book, I mean, if you, 2 to the power of 6, no, that's too much, no. If you really count, I don't know, 6, 7 cases, business relevant, realistic cases. That means 7 tests besides the 4 we agreed together multiplied by 4 mocks. That means pain. So that's my point here. When you have some algorithm, some part of complexity which is somewhat decoupled from the rest, you need to think to cut it out completely. Cut it out completely in a pure function. That's what I'm going to do next. Let's see how we do that, because it's not easy. It's not easy, really. The problem is that if I just take this part out, first attempt, Zorro. What's Zorro? Control Z, probably, but let's see. Is this function pure? Is this function pure? No, why not? Changing, what changes? The list, exactly. The list here changes. Changes in here. It's a pure function. It's pretty cumbersome to test, so I want to go to pure functions as much as I can. But right now, this is not pure. So, Zorro. Back. Let's try again. The problem is that the final, the used coupons here, the used coupons, goes into this block and is added to. My initial naive idea would be to bring this closer. But you see, I'm going inside the 4. Ooh. Fortunately, this doesn't compile, because I've used that variable after the 4. How to put it to see the whole code? You need to see the whole picture to understand. The use coupons is not allowed to be here. It's supposed to stay outside of the 4 and accumulate values as I compute them. Make sense? It needs to stay out of the 4. Damn it. So my hands are tied. Or not. What I'm going to do next is a refactoring that many people are afraid of, but it's very, very useful here. I'm going to split the loop. Folks, how to put this? This is streamed. In 2018, December, a book came out. It's called Refactoring 2nd Edition by Martin Fowler in the chapter Code Smells, that is what stinks in code, there is a special chapter called loops. So since 3 years ago, 4 years, loops are considered to be a code smell. If you see a 4, you should say, ew, 4. Wow, what do you mean? If you join the reactive programming nightmare after lunch, you're going to see much more interesting, extreme functional programming in there. But here, what I want to do is to cut the 4 into pieces first. What do you mean cut it into pieces? Realize that the 4 is doing 2 things. The first thing at the top is retrieving prices from different sources. The section at the bottom is computing and applying the coupons to the prices. So why not cutting it in 2? How about that? But then the first 4 over here has to return out the prices to use in the second 4. You see the point? I will section the 4 in 2. Make the first 4 produce a list of fetch price. How do I call this? What happens in here? This is resolve prices. Oh, okay, then I know it. It's a map of a long custom product ID to a double called resolved prices. All right? And then these resolved prices are filled here, put product ID and the price, fetched from my or from the API. And then from the resolved prices, I'm going to get the product ID price in the second loop. Make sense? So I've cut the 4 to do the different things it was doing into separate loops. Okay? Then let me move the variables. Did I tell you I'm a clean code maniac? No, but I think it's obvious. Okay, so if you want to join the club, join the community. All right, so this thing over here is a resolve prices. Now, what are we left over with here? Well, let's give it a try. I will extract this section out, but I want you to realize, I told you this is not an easy example. If you have a very good look at the box I'm going to extract right here, you are going to see that this box is returning out 2 things. Is returning out the prices here and returning out the coupons here. Do you see this? You can't possibly return 2 results at once from a function in Java, thankfully. Thank you. God knows what happens in Java 25. But at least now you can't. Are you familiar with destructuring in TypeScript or JavaScript? For now, we're safe in Java. You can't have a function returning 2 values at once. There you go. Unless some guy returns an object array. Oh, I know, a tuple. Are you familiar with the tuple keyword? Who knows about the tuple keyword? Oh my God, it's 90% of you. Oh my God, wow. Whew. Okay, good. So I'm not gonna use tuple. Okay, thank you. Anyone here, tuple 13? No, tuple 7? I don't have the library here. What? Clean code Java, just a second. Tuple 3, tuple 13. Well, I mean, why not? If it's there, someone should use it, right? Like, all right, no, goddammit, no, stop. Okay, so tuples are lacking semantics. Tuples don't mean anything. It's just a grouping of int, long map list of, okay. Here, however, I want to avoid tuples. Let's see what happens in Java 17, in IntelliJ, if you extract a function returning 2 values. Anyone knows? It's a recent addition to the feature of IntelliJ. If you're trying to extract a function returning 2 results at once, in Java 17 with IntelliJ latest version, since 3 months ago, what do you think is going to happen? Not pair. What? Record, because I said 17, but what more? What's going to do? What's going to do? No idea, huh? Master, do you want me to create a record? To hold the results that I see you return from your block of text. Are you not? Yes. Price calculation result. Because if you allow me to create a new class, I can then extract your function. Calculate result prices. Do you see this? Look, let me put the record before. Look what it did. It introduced a new type so that the new function can return the new type here, which is then expanded into final prices, use coupons. Several months ago, they've added this feature. Like, what the heck? But that is a common price to pay if you want to go for pure functions in real life. You're going to have to return multiple things at once. So let those tuples aside for a second and do this. Private record. No one knows. It's just, but I'm conveying the idea. Final prices use coupon. It's not tuple tree of long string map of list of too long. It's record. With semantics. Beautiful. Angels are singing in this moment. I'm like, good. Now, this function. What do you think about this function? Is this function pure? What? Just look. So pure means no side effects, same result. Let's see each. Do I change anything? Well, I'm going to track down products. Product get. If I find someone doing some changes in a get for ID, I'm going to pay the guy a visit. And I'll bring a friend. Get ID is just a getter, right? So, but then the apply might be interesting. What does apply do? If you check a bit, you're going to see that actually it's not. But what is applicable before? Is applicable for returning. Okay, so nothing really changes in here on the product level. The map, do I change anything in the map? No, I just get from it. The customer, do I change anything in the customer? No, I get the coupons. But wait. Why am I passing the customer if I just need the coupons? Right? Remember the first rule? It pass less information to a function. So I'm going to take this out and add this instead as a parameter, like this. Done. Okay? To simplify testing, because yes, you guessed it, I'm going to test this baby. What just happened? Let me undo. I took an expression from here and told IntelliJ, can you please do this on the color side? Here, please. IntelliJ said, yeah, sure. It's called introduce parameter. But after doing that, it realizes it doesn't need customer anymore. Look. Boom. Gundam style.
Gangnam style.
Okay. Good. So now the question, is this pure? Yes, doesn't change anything. Does it return the same result? Well, as far as I can see, it doesn't hit any network. Let me try something. Static. Oh my God. Static in my word, in my code base? Static? Isn't static frowned upon? Isn't static illegal? Don't you burn in the OOP hell if you do static? I'm not sure if you have the same memories like I do, but 10 years ago, if you did static, someone would hunt you in the office. You did static. That's not OOP. What would Uncle Bob say of you, right? So it's static is long considered already to be not OOP friendly. Okay, but if I make a function static in a dependency injection project, that basically states that basically this static means no networking. Because in the systems that we write today, if you want to do networking, you're going to inject yourself a repo, a sender for messages, a web client, a REST template, something you're going to inject, right? To propagate trace IDs, for many reasons. We don't do network unless we do it over a dependency. So the moment it's static, you are declaring that you don't depend on networking. Next thing you look at to see whether you are changing stuff in here. If coupon were really immutable, it will be much easier for me. In this project, in this example over here, it is not really immutable. So I had to check, do I change anything in there? But if these were immutable, and if I would use instead immutable list from Guava, an immutable map from Guava, then I could be sure that nothing can change in this function. You see what I mean? Immutable collections, holding records or immutable objects inside. because I don't have that kind of immutability in this example, I had to look. Do I change the list? No. Do I change the map? No. Do I change no, I don't. Perfect. This is pure. All right? Now, what goes next? This is where all my complexity went. So you know what? If this is where the complexity is, let's test it. What did he do? He drilled the hole. I just broke the encapsulation again, but this time is not a mistake. This time, inside the class, I isolate the part that has most complexity, let's say 5, 7 tests or more, into a package-protected pure function that I target with my tests, allowing the remaining of the functions in this class to wrap around it. So I will still have the compute prices working as an orchestrator, the entry point, the public, right? Who does the find by ID in the repository, find all by ID in the repository, resolve the prices over the network, calculate the prices, and mark use coupons. This is a high-level function calling the low-level details below, right? This is not pure because it does network, okay? Then the function it calls over here, resolve prices, this is not pure because it does network. Okay, good. And then it calls into a pure function where most of my complexity is. That function returns me a result that I use to fetch the actual computation result out. Good. But this function, since it requires so many tests, I will call this the functional core of my flow. Functional core, a pure function taking results, parameters in, returning results out. And I want to target my tests on this baby. So let's call it traditionally do calculate price. I don't know who invented this idea, but it's good. And then in whoever I call the compute prices, let's see what happens with my tests if I target the new class. Let's take it baby steps. So let's call do compute prices, do calculate. Oh, by the way, why did I use a different name? Wrong. If it's compute, it should be compute. Use synonyms. Do compute prices. Thank you. Do compute prices. Now, what does it take as an argument? The products list. It doesn't take a list of products that are then fetched using some repository mock. No. Instead, it just takes the 2 products. I'm gonna let the old code here, and I'm gonna write it again. It's gonna take the list of product 1 and product 2. It will not hit any repository. It will just take the products on a, how do you call that? On a silver plate, master, the product. Right? No repository call. Then, resolve prices. Back before, I had to do a network call here to fetch the price, to know that the price for the product number 2 is 5. Now, with this, I'm just going to say map of. The product 1 is, I think, ID 1, has the price. What is the internal price? Let's read into here. The internal price was 110D for that. Here, 10D. The price for the second product was coming from remote. It was 5D. Okay, 5D. These are the prices already resolved. That pure function will not call any network. And the last thing, the coupons. And I have the list of coupon 1, coupon 2. Done. That thing over here returns me a variable of type result, which forces this to become public, the record we've introduced with IntelliJ. The call is to a static function, like this. And how do I get the coupons out? Well, this is our friend, the captor. I bet some of you did not see a capture until today and will have a very hard time sleeping tonight. Wait, what the heck was that again? I saw something magic in there. What was that? I don't need the captor to get the coupons out. No, I don't. Instead, I can just go, instead of this, I can say result dot coupons, used coupons, right? Contains exactly, assert that first of all, assert that, contains exactly the coupons that were used, which is 13L. What did I do wrong here? It's coupons, that gives me a list of coupon, the whole coupons. But before, okay, I have to get the map, right? ID. Coupon, am I doing the right thing? Something is wrong. So the do compute prices produces me the coupons, all right. And how do I identify the coupons? Oh, I don't need to use the ID in any way. I will just check that those are coupon 13. Wait a second. 13, no. This, set off. What do I do here? So which coupon is used? A marked use coupon equal 13. I'm missing something. Coupon 13. It should be coupon 1. Sorry? Is this the right one? I'm not sure on that. Let's see. And then the result would be the prices, would be the get the prices dot assert that, yes, right? Contain entry. I feel I broke something. But we only have 10 minutes left. Let's see if I did not do anything wrong. Oh, the point, let's see the error. Unnecessary, clean, and maintainable test code requires you have mocks that you don't need, says Mockito. And I know, indeed, I don't need to do when find by ID with my pure function. The pure function will not call the outside world. The pure function gets everything it needs in the inputs, all right? I don't even need to create a customer, as you can see, right? So the test shrinks a lot. I don't need any of these. Nothing. Bye-bye Mockito. Bye-bye Mockito. Right? Input in, input out. Nothing fancy apart the inputs. So, pure functions are simpler code, which is also simpler to test. You're just going to assert the results of the pure function. You're not going to verify capture. You're not going to when then return. You're just going to input out. Of course, there are trade-offs. Nothing is for free. We saw that we had to introduce a new object in there to report the results. Also, maybe you need to take more arguments in the pure function to be able to compute everything inside. Okay? But this goes in this spirit that the complexity you have in an application should be pushed into a functional core, into this kernel of calculations, allowing the remaining logic that fetched results, that fetched the data from outside, send it from outside, and changed state, keeping that outside. So you have a flow. The first thing you do, fetch, fetch, fetch. You call the computations, get the results back, change state, send, insert, return. But the center remains pure. Imperative shell, functional core segregation, right? So the heaviest complexity should be extracted in pure functions. At least the functions which are less coupled to the outside, all right? Now, one last slide for you. Several more ideas about the immutable objects. Immutable objects, just to make sure we are on the same page. Objects you cannot modify after instantiation. Be very careful about your fields. Should be final value in Lombok or record. And what you refer to other objects, those objects should also be immutable. Okay? So mind the collections, if I say that. Now, you have 4,000 unit tests. You have 100% test coverage. Woo. 100. Anyone having 1 or 99, more than 99% coverage? On one hand, 2 hands. 2 hands in 200 people. Interesting. 3 hands. Congratulations. But then in my case, they are using immutable objects. Look at this code. They have 100% line coverage. 100. What is it? CERN? What are they building in there? See? 100%. The particle accelerator, 100%. Mutable order discount. Apply discount order. Compute price order. Do you see the code? What's going to happen if I swap the 2 lines? What? The test will not fail. The tests, because they wrote tests for each method in part, the tests will not fail. I will still call apply discount, still call compute price, but in the wrong order. If you swap the 2 lines, you're going to have bugs in production despite 100% test coverage. Because you used mutable objects. Of course, there is the so-called OCD, paranoid testing, which uses in order to check the order in which you call the methods. Who does that anyway? Don't raise hands. This leads to extremely hard to read code in the cumbersome way too. The better approach is to not rely on tests anymore to fix this, but to rely on the language, on the practices, and to favor immutable objects. What's happening here is that the tests are putting you to, because if you have a bug despite 100% test coverage, your boss is going to come to you. I promise you. Boss is going to come to you and ask you, you spend a lot of time writing those tests. How did you have a bug in production? If you have two ways here. You either put in order, paranoid testing everywhere, or you change your habits and you favor more immutable objects. Because if order were immutable, you can't change it inside. Apply the discount, you realize, change the state of the order. If the order is immutable, the only way to apply the discount is to return a new order, you see? The only possible way to change an immutable object is to change a clone of it and return the new instance out. And now if you swap the two lines, what's going to happen? If you swap these two lines, it will not compile. So you see what we're using? We use the compiler to check for these problems, for this temporal coupling between the order of the line. So tests can help you up to a point. Beyond that, you need to change your practices at some point. And that's why I have clients today. The biggest of one in Netherlands, which basically doesn't have any setter in the entire of their code base. I'm sure there are some people from that company in the room, but I can't. It's not okay to say the details. But the point is, not a setter in 20 projects. Big company, right? Everything immutable. They're using the fancy library called immutables, if you heard of. Anyway, the point is, we need to come to a summary, to a conclusion. What did we learn today? We started with that test that had 7 mocks, mock. The test had when, then, verify, and the production code had 4 lines. And we said, what the heck am I testing in here? If that ever happens to you, you can either collapse that silly production code, or you can test more at integration level or social unit test to prefer longer scoped tests and not test every single method alone. Test flows, test responsibilities. Signatures in functions should take the least amount of information. The more complexity you have to write and to test, the more should you invest in building new data structures to support that complexity. Mind that today with microservices, this is rather the exception than the norm. You might be just enriching some data from there, push it further, and not do a lot of logic yourself. But if you do a lot of logic, create structures to support that logic. Domain should be kept safe against external ugly APIs or libraries that try to pollute your code. Complexity should be split horizontally, high level, low level, or vertically. What's shawarma, what's tzatziki, unrelated to each other. And when you split stuff up, you make sure you understand what things are doing, clear responsibilities, right? Don't just blindly mock all dependencies. And this is very important. I had the discussion in the break. What I want this to feel like is just that when you have to write a test for your new feature, don't just think about your method in isolation. Try to look around a bit and see whether you can test a bigger flow. Maybe up to the API to the database, maybe just 2 more classes around you together. Maybe it's very easy to include a larger test. That larger test will be more resilient against changes in the future, right? Good. Decouple complexity. When you have complexity, extract it in pure functions. And then pure functions are easier to test, easier to reason about. An immutable object can protect you against temporal coupling. Problems like this, swapping lines, that can cause problems. So, we should at all moments aim to create a design which is testable. When do we start writing tests? When you ask this question, some people will say, at the beginning, TTT, right? Okay. You are very lucky to be able to work in a team in this style, if you are. Congratulations. Not all of us are this lucky, not all of our projects deserve this honor. Really. Some people will tell you even earlier. do behavior-driven. Cucumber tests feature files, right? Maybe, with the business next to you. Okay, but most of us test too late. If you test close to the end of your feature, no matter what the tests are telling you, you won't have time to act on that feedback. You're just going to want to ship your stuff. The earlier you test, the better you understand the problem, the more design feedback you get, and the more confident you are that you don't break stuff when you clean it. So if I were to summarize everything in one single image, test early enough that you have time to act on what tests are telling you. Tests will be telling you stuff. You need to reason, does it make sense or not? Maybe somewhere in the first 30%, 40, 50% of your time frame, you should already have 3 or 4 tests in place. And at any moment, any code you write, think from the beginning, how am I going to test this, right? Because if you don't care about your design, your tests are going to hurt you, and that's good. That's why we don't accept pull requests that don't have tests, because we want people to suffer if they do bad design. Right? All right, more reading, of course, a lot of reading, and with that, I think I'm done. If you want to join us, this is the QR to join the community, and we can keep in touch monthly. All right, thank you very much, and let's head for the food while it's still there.